Not only that, but we're also supposed to see cards stating or showing the insulation depth. And this section is exactly the same as what you have in your code. I verified it word for word, saying that you need to have these markers installed throughout the attic, one for every 300 square feet of attic space, facing the attic opening. And so you can take a quick glance and verify. But even though these cards are required, we all know what I think we all know what the insulation contractors like to do. They like to mound up the insulation in every one of these cards and make sure that it always looks good. This is the only card I've ever found in my history of a home inspector that didn't have the right amount of insulation showing on the card. The card was actually low, and this is one that was in the farthest reaches of the attic. I had to climb to get to this. So they didn't think anybody was going to see it. But normally they really like to mound up the insulation. But we're not concerned about that. We're concerned about insulation everywhere else. And so I'm encouraging you, get out there and take a tape measure or a steel ruler and check the depth of the insulation throughout the field in the attic. And, you know, maybe you need to crawl on some trusses. Don't fall through a roof. Don't step on can lights. Don't do anything bad. Don't put your feet where you can't see where you're putting them. But if you can get up in the attic a little bit and take different measurements, you'll find a lot of these insulation contractors treat that insulation like it's worth its weight in gold, the way they short attics. It is unusual for me to do a new construction inspection and find sufficient insulation depth. It's almost always about 20 to 25% shy of the stated depth throughout a lot of the attic. Not the whole thing, but a lot of it. There I'm using my tape measure. I don't like using the tape measure because it's got a bigger end on it. I like to use just a flat steel ruler. That's really my preference. And then you're not pushing a little hole into the insulation. You're just making a thin little slice into it. And my trick is I take my steel 3-foot ruler, and I only bring it along on new construction inspections. That's the only time I'm actually getting nitpicky about the insulation depth. And I'll just take a little piece of orange electrical tape and I'll wrap it around my ruler at the depth that the insulation is supposed to be installed to. And then I'll stick it in a bunch of various places, and it makes for very nice visual evidence in my report of what was supposed to be installed and what really was installed. And I'll take a bunch of photos. So and I'll take nice perspective photos like this. So I can't have a builder coming back and saying, well, the home inspector was just being nitpicky. They measured one little area. The rest of the attic's fine. We don't need to do anything about it. No, I'm trying to give them compelling evidence that this was the whole attic. This wasn't just one tiny little area that I measured. And that's providing value for your clients. Because if the builder can push back and fight this stuff, they will. And this is what the inspection report photos look like. All right, that gets a little repetitive. Something else that's fun to do if you have the opportunity to do it. If you're doing a pre-drywall inspection and you get up inside the attic before they've installed all the insulation, you may have the chance to look for attic air leaks. And I could wax on about attic air leaks for a long time, could do a whole class on the importance of identifying these, but just about all the attic problems we run into, ice dams, frost in the attic, mold, condensation, all these different things. It's all the result of attic air leaks. And when I say all, I mean 95% of it is attic air leaks. Unsealed passageways for warm, conditioned air to leak up into the attic space. Probably not as big of a deal for you guys in Virginia as it is for us in Minnesota in a colder climate, but I know it's still problematic for you. And this stuff matters and we're looking for it. So if I can get up inside an attic before they install the insulation, it's really easy to find this stuff. And what you're looking at right now, I'm standing up inside the attic and I'm looking down at the top plates of a couple walls where they join each other. And this intersection should have been sealed. I am not being nitpicky about this. This actually is a big deal. And if the insulation is already installed, well, if we got a good difference in temperature between the attic and the rest of the house, I can use an infrared camera. And when I say good difference in temperature, I'm thinking maybe about a 20-degree difference. I can use my infrared camera in the attic and I can find a lot of air leaks if they exist. And here's just an example. This is wires penetrating the top plate of a wall. We got this tiny little hole, and I was able to easily find that through 1.5 feet of loose fill insulation. I didn't go digging around in the attic in various places just thinking, hey, is there an attic air leak here? No, my infrared camera picked it up plain as day when it got a good difference in temperature. And this stuff matters. It leads to frost accumulation in the attic. That's what we're seeing here. This is new construction. Builder didn't seal up one of the penetrations right, and we got tons of frost coming in here. This is brand new. This is what it looks like when the house is new, and you can see there's already black forming down here. What's that going to look like 5 years from now when the sellers go to sell their house? That's going to be a nasty mess. So yeah, this stuff absolutely matters, and we look for it every time. I'm looking behind me. I'm waiting for my internet to come back on so I can get off my phone's internet. And I apologize for my dog. He's a big boy. There's nothing I can do about him. He'll bark every now and then. All right. Other stuff we're looking for in the attic. Obviously, we're looking for damaged trusses, cracked trusses. I think a lot of the time it's just from people taking a boom truck and unloading a pallet of shingles all in the same spot, overloading it, maybe mishandling of trusses on the job site. We find a lot of this. And when we call this out for repair, there's 2 ways to do it. Either you get an engineer to design a repair, which is kind of crazy. I don't think anybody's really going to need an engineer to design the repair. Really what you do, a new construction, you just go back to the truss manufacturer and you have them give you the repair. They're going to have spec sheets on exactly how to fix this. They're going to say, all right, take a couple of 2x4s, go on either side, use 10D nails and 1 nail at the top, 1 nail at the bottom every 3 inches and a staggered pad, whatever it is. They're going to be very specific about it. It's going to be a lot more than you would probably guess it would be. It ends up being a lot of wood and a lot of nails to fix stuff like this, but they've got spec sheets showing how to do it. And so when you find stuff like this, I'd say, have it repaired in accordance with the truss manufacturer's instructions and have someone verify it's done. And ideally, now I've never seen this done. Never seen it done, but ideally, you're going to have a sheet up in the attic, like some printout from the truss manufacturer showing how the repair was supposed to be done. And it's going to be like stapled to that repair. That would be a perfect world. And I don't like going out to do re-inspections for stuff like that. It just puts me in a bad position. Not to say I won't, but if I'm asked to do it, I'm going to want a lot of documentation. I'm going to say, all right, if I'm going to inspect this repair, I want to see who's doing the work and what did you ask them to do? That's a huge one. What exactly did you ask them to do? Sometimes I will get myself out of doing re-inspections simply by saying, look, you didn't even tell them to do what I told you to do. You told them to fix it. I told you to tell them to get the truss manufacturer's installation instructions and use a blah, 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 blah. I was very specific. You said fix it. When I go out there, I guarantee it's not going to be right. You may want to rewrite your language here. So a lot of the time I'll just head off these re-inspections by looking at the documentation ahead of time. But again, you know what you're looking at here. We got damaged gusset plates, trusses separating. This is all a big deal. It all needs to be repaired, and it can be repaired. I should say it's important. I shouldn't say it's a big deal. It's not a big deal. It's just important to have it fixed. We're looking for bath fan exhaust. One of the first things we do, and man, this applies to every home inspection, not just new construction. Start your inspection by going through the inside of the house, giving yourself a tour, and turning on everything that removes air from the house. Clothes dryer, kitchen exhaust fan, bathroom exhaust fans. Turn all this stuff on, and as you're going around the outside, verify there's air coming out of all of these terminals. I mean, keep track of them. Make a mental note. Okay, we got 4 bathrooms. I need to find 4 bath fan terminals at the outside. And We'll come back to this. It gets screwed up at new construction too. I mean, I think it's even worse at existing houses when people have had a chance to modify their homes, but you'll find defects at new construction. Now, even if I hadn't been able to find this bath fan duct in the attic and see that it was disconnected, I probably would have figured it out while walking the roof, and I would put my hand underneath that bath fan terminal and I go, huh, there's just about no air coming out of here. We've got a problem. But it's nice to see it firsthand in the attic too. And it's easy to understand why. They take this sheet metal, they got these tiny little Tex screws, and then you get someone who comes in and they nail the damper down and it knocks that metal right off there. And so how much of a mess are you going to have in the attic after this has been blowing warm, moist air into the attic for years and years before someone gets up there? Always get inside of every attic space. This was a fun one. This is actually not a new construction inspection I was doing. It was on about a 10-year-old townhouse. And there was just one townhome in this row that had no snow on the roof. The units to the right and left, they all look great. Nice snow-covered roofs, nice uniform level of snow. And then the one unit had no snow at all. And they never insulated a huge portion of the attic. There was actually 2 attics at this house. One attic got insulated, the other attic got completely missed. New construction. And here's another version of that. This is one where it had 2 attics. Here, you know what? Here's the 2 attics. We got one attic on the left here. That's the upper one. We got a lower attic on the other side here. And as I'm going around the inside with my infrared camera, we scan just about everything with our cameras, found this big cold patch at the ceiling. And it's a cold day outside. I'm going, why the heck is the ceiling cold? Oh, they didn't insulate it. That's the only logical explanation. And I couldn't get at that lower one. This was a Parade of Homes house. I don't know if you guys have that in your area, but it's like where the builders show off their houses. And they had it staged. The realtor parked his boat there, like, hey, this could be your boat too. You could be living this dream. And so I couldn't get at the attic access for the garage. And I was a little frustrated, but it's like, all right, usually there's not much to see in garage attics, but because it was all cold, I made a stink about this, and I made him come out, and he moved his boat, and he had such an attitude. He was such a jerk about it, telling me my toy's broken when I told him my infrared camera said it was cold. But he moved it, and sure enough, no insulation. They completely missed the insulation over the lower attic space, thinking it was all garage space, but there was a lot of dwelling space above that too. That was what caused the cold spot here. All right. Another version of it, just don't ever take things for granted on new construction. This is another big new house. This is what an 11-month warranty inspection we were doing. One of the things the seller the owner complained about was that she had uneven heat throughout her house. Her house would always be like 80 degrees, and she would set her thermostats down to 65, 70, but her house was always uncomfortably warm no matter what she did. And it had 4 heating zones. And one of those zones was for the sport court. There's some infrared images of her sport court. Now let me go back a slide. You see it's winter. It's cold outside. Here's her sport court again. And you'll notice in the infrared image, if you've taken an infrared 101 class, you know that if the warmest part of the wall is the studs, you don't have any insulation in your walls. That's what it's telling you. They forgot to insulate the sport court entirely. And then in the ceiling, they missed the insulation at a lot of the ceiling. They insulated some of it. I don't remember why, but they didn't insulate most of it. So this is the 4th zone, and the thermostat was trying to heat this all winter long. The furnace never stopped running all winter, trying to get this sport court up to temp. Huge project for the builder to fix this. Not only that, but the builder ended up paying her back a ton of money because she was spending a lot of money on heating bills, more than paid for my home inspection. I'll tell you that. But don't get complacent about this stuff. Don't expect that because it's new, they're going to get it right. Everybody messes this stuff up. That was a huge, expensive house. More stuff to find with the infrared camera. And, I surely would have found this by counting bathroom exhaust fan terminals, but if you can actually get photos of the defect, it's a lot more compelling. This is just a big red infrared explosion, this big hot spot in the attic. I crawled on the trusses, dug down right where my flashlight is shining, and here's what I found. This is the end of a bath fan, and there is no duct coming from it to the roof sheathing. So again, count the terminals. All right, just for time's sake, more stuff. Big water damage at this house. They had leaking. They had to tear out all the drywall going up and a bunch of the flooring. Just a huge mess. They had this leak. They couldn't figure out what the problem was. And note the thermostat in here. It's set to 75 degrees. It was only 62, and it wouldn't get much warmer. The problem was yet another house where they completely forgot to insulate the attic. And the builder's spending all this time trying to fix water damage. Man, it's unbelievable. Okay, enough on insulation. Fun stuff looking at roofs. One of these days, I always swore I would wisen up. My home inspection process was always to walk the roof first. I just like doing it that way. When I'd show up, I do my thing on the inside. I turn on all the bath fans, take a tour. But one of the first things I like to inspect was the roof. But if I was a little bit smarter, I would inspect the attic first. And I'd look for areas in the roof where I didn't want to put my foot through a hole. And that's exactly what you're seeing here. It's just there's supposed to be a roof vent here, and they shingled over it. You can kind of figure it out looking at the roof that they're short one roof vent. We got 4 here, or should have 4 here, but new construction, you'll see this stuff all the time. Anytime you see a radon fan, I'm guessing your building code does not require the installation of radon systems. But if you have a builder who's been asked to do it, or a builder does something out of the ordinary and they put a radon fan in, look to make sure it's right. I found builders they don't do a lot of these. They don't know the rules. And when they do it, they mess them up. And that's what you're seeing here. You're seeing a radon fan on its side. They're always supposed to be vertical. The idea is when water comes through that radon vent pipe, it needs to pass right through. But when the fan is on its side, it's not going to work that way. So radon fans need to be installed vertically. All right, we'll move on to roof coverings. Ice barriers. I'm not even going to talk about that. You can't see them anyway. But I'll encourage you guys. And when I say guys, I'm sure there's some women in the group. I'm being inclusive. I'm talking to everyone when I say that. I strongly encourage everybody to walk roofs. And if you're not walking a roof, at least take a ladder and lean it up against the roof in a bunch of places and lift shingles. On new construction, this is so important. A lot of the time you'll get out there before the shingles have even had a chance to seal themselves. And even if they have sealed themselves, dirty little secret of mine, I keep a putty knife in my tool pouch, and I will break the seal on a shingle or two. Oh yeah, I said it. I'll do it. I'll break seals, and I'll lift those shingles up, and I'm checking for proper nailing, and I'll do it in a bunch of different areas, and I'm inconspicuous about it. And when I'm done, drop it back down. Next hot day, it's going to seal itself back up. I have not done any harm, but I'm checking for proper nailing. And man, once you start looking for this, you start finding it all over the place. And I'm talking about asphalt shingles, of course. That's probably easily 95% of what we do in Minnesota for new construction. I'm hoping you guys have the same thing, or at least something similar. Otherwise, I'm wasting your time. But what you're seeing here, there's no nails at the edges of the shingles. And then another example, these are overdriven nails. They set the pressure too high on the guns when they were putting the roof down, and the nails have punched right through the mats of the shingles. This is going to void the manufacturer's warranty. Anytime you see any of this, the warranty is null and void. That's what you're seeing here. All these nails have punched right through the mats of the shingles. And when I see this stuff, I don't like to be the bad guy. So I try to give 2 options. I'll say, there's 2 things you can do here, because I found this everywhere. And again, just like the attic insulation, I'm not going to take one picture and say, hey, the nails are overdriven, have this further evaluated and have someone check it out. If you do that, the builder is just going to send the rep out there and say, yep, it was just that one spot. Everything else is good. We fixed it. No, you got to get in a bunch of different areas. And even if you're not walking the roof, lean your ladder up against a bunch of areas and check it all over and make it clear that this is not isolated to one spot. It's pervasive. And so I'll say, I found this all over the roof where the nails are overdriven. This violates the shingle manufacturer's warranty. There's two things you could possibly do. One, simply get a letter from the manufacturer saying that they will still honor their warranty. I haven't seen that ever happen, but you don't want to be the bad guy here, right? So, you know, because the builder is going to say it's not a big deal. So if it's not a big deal, get that letter, get a letter from the shingle manufacturer saying it's fine, or you could tear the roof off and start over. Those are the two solutions I know of. That's it. And I'm not being the bad guy here. You choose. If it's not a big deal, it shouldn't be a big deal to get that letter from the manufacturer. But I have seen many a roof get torn off and completely redone because that is a pervasive defect. You can't fix that. You're not going to lift up every single shingle. You're going to tear up that roof doing it. And what happens if it's not fixed? You're going to have shingles blowing off. And we've seen it happen at countless new construction houses. Houses are brand new, and you already have shingles coming off because they didn't install the nails right. They overdrove them, or they put them in improper locations, or they didn't use enough. Now, another defect you might find in new construction is underdriven nails. As far as I'm concerned, this isn't nearly as big of a deal. You can see underdriven nails from the ground. If you stand at the right angle, looking up at the pitch of the roof, you can see all these pop nails. So it's really easy to find them, and it's not a big deal to fix it. You get someone up there to pound the nails back down. If the nails have actually punched through the mats of the shingles, those shingles ought to be replaced, but it's easy to find them. So not nearly as big a deal with underdriven nails. And this is always a fun one. I like to ask if when we're in up and says, no, that's probably a ridge vent. We're good to go. And the answer is no, that's not a ridge vent. There is no ventilation at all. As you can see from the sheathing, someone had planned for a ridge vent, and then somebody else ripped pieces of OSB and put them in place here, and they completely covered it up. This attic had no ventilation whatsoever.
Hey, Reuben.
Yeah.
You lost your sound for just a second. Could you go back to the beginning of that discussion about the ridge vent?
Oh yeah, sure. And I just got a notice on my computer saying my internet connection was unstable. So why don't I turn off my video, and that should help. Okay, so what I was saying about the roof here is that when I'm teaching in person, I like to ask everyone, all right, what's missing here? And then someone pops up and says, ventilation, there's no vents. And then someone else pops up and says, but that's probably a ridge vent. And the answer is no, that is not a ridge vent. There was supposed to be a ridge vent there. You can see where they cut the sheathing back. They held it back. There was supposed to be a ridge vent installed right here, but the next person who came in didn't understand what was going on. They ripped tiny little pieces of OSB and fastened them in place, and they completely covered over what would be a ridge vent. And I don't even remember what the rule is on OSB. I'd have to look up the rules. I wasn't prepared to talk about it, but just thinking about it, you can't even have pieces of sheathing this skinny. I know there's a minimum thickness for OSB, or a minimum width for OSB. I know you can't have them that skinny going in between because you don't have enough strength there. But that's besides the point. The main point here is there's no ventilation provided. And I don't know if you can see it clearly enough in this photo, but this insulation is yellow. There's drip marks everywhere in the insulation because it was literally raining in the attic. There's on new construction, you're going to have a lot of moisture. The houses need to dry out for a long time to get to kind of equilibrium from all the paint and everything else that gets used. And that moisture had nowhere to go. And it was just raining inside the attic because there's no vents. All right, more on roofs. Ridge shingles, always pull up a couple of ridge shingles. If you've done any roofing, you know that on a traditional roof, you're probably going to use 1 1/4 inch nails. And then on the ridge shingles, it's a lot thicker. You need to go through a thicker shingle, and then you're going through other shingles. You need to use 1 3/4 inch nails. If the roofers are being lazy, they're not going to switch the nails out in their guns. They're going to use the exact same nails, and it works fine for a little while. But eventually you get those ridge shingles blowing off. And if they use the wrong nails, just barely the tip of the nail is going to penetrate the sheathing. And you can basically just grab onto that ridge shingle and you can lift it up and you can pull the nail right out of there. And that's what I'm showing here. They used the wrong nails. They didn't switch them out. So that's something we're always good about checking at. Check the ridge shingle nailing. And if they got it wrong, you're going to have sheets of ridges blowing off. Might not be blowing off at the time you're doing your inspection, but that's what it eventually leads to. And then kick out flashings. These are, I don't know when they started being required in your area. In Minnesota, these have been in our building code for the last 16 years. It's been a long time where we've been requiring these. It's nothing new. And it's just a little piece of bent up metal at the bottom of a roof wall intersection to direct water out from the wall. We should see it. And, this is stuff we write up on every home inspection if it's not there. And we don't always say, if it's a 20-year-old house, we're not going to say this is improperly installed. We're going to say we're missing kickout flashing here. And it's a little piece of metal that helps to prevent water intrusion. I recommend you have it added. But this is what it looks like when it's not installed. Not only that, but we've got just a horrendous flashing detail here where we've got the stone siding is brought down tight to the asphalt shingles. We're going to have water wicking up into the stone siding. I talk about this at length in my water intrusion class, but just nasty detail. New construction, bad detail on this one too. There's no kick out flashing. Look for that. We should find it every time. And this little piece of metal is just about nothing. If you think like a drip, where's the water going to go? It's going to go right underneath this. Kick out flashing should never have a cut here. All it needs to be is a bent up piece of metal or a pre-manufactured piece of metal. It does not need to have a cut there. And when it does, water does nothing. It's going to go right onto the siding. So ugly detail. This is just a laughable detail. I wish I could see you guys' faces. I know you're all laughing at this. Where's the water going to go? And then this just another ugly kick out flashing where they've got it bent at a 90-degree angle. So you're going to have water splashing like crazy up against the siding. I'm going to expect premature deterioration of the siding there because of this. All right. Missing shingles. We could go on and on about that. For decks, I'm not going to talk a ton about decks. I'm sure Douglas Hansen is going to talk about them a lot, but if you don't already have DCA 6, ask your neighbor, ask the person sitting next to you, because they surely have it. It's a free PDF. It's put out by the American Wood Council. This is not the building code. If you're referencing DCA 6, well, you know what? My advice would be just don't reference DCA 6. It's not adopted by the building code. I was talking with Douglas Hansen. He said it is actually going to be adopted by the building code, a future version of the IRC that you guys have not adopted yet. Minnesota is not adopted yet, but I heard it's coming. Just what I heard. I haven't seen all the details yet, but DCA 6 is like the Bible on how to build decks. And if you inspect decks, you need to have this. And it explains exactly what the code means. And it teaches you how to build a deck and inspect a deck in accordance with the IRC. So really good book to have. Just a few examples of some illustrations they've got in there, really helpful stuff that, I mean, the code spells this out, but they've got really nice illustrations showing you exactly what the code means. For instance, if you're attaching a beam to the top of a post, a couple ways to do it. You can either bolt it to a big chunk of post, or you could use a manufactured post cap. This would not be that. This is new construction. They left a little sliver here. Now, if this was a 2-member beam and they left a big chunk, that would have been okay. But instead, they just pushed it out over the edge. Just laughable new construction stuff. Now, this is not, as far as I know, this is not any type of listed bracket for that post to beam connection. However, this is the beefiest bracket I think I've ever seen in my life doing this job. Am I going to get nitpicky and say, hey, we need some kind of listing? No, it looks fine. It's going to do a much better job than any bracket I've ever seen. I'm not going to say anything funny about that. Simpson Strong Tie, if they haven't already done a presentation for your chapter, well, maybe get them out and do a presentation. I know they're on a national tour teaching people about this all over the place, about how to properly use their products. They do a good job of educating the builders, the home inspectors, the building officials in our area about how to use their products right. One of the biggest defects we find with their joist hangers is that people end up using the wrong nails. For a long time, they made these nails that were meant to go into joist hangers at a 90-degree angle. So the nail would come into the side of the joist hanger, and they didn't want it coming all the way through the other side of the joist. So they made these special short 10D nails, 1.5-inch 10D nails for going in the sides of joist hangers. And then they call them joist hanger nails. Well, of course, so everybody thought that's what we need to buy to fasten a joist hanger to a ledger board. And everybody started using these tiny little short nails. And the manufacturers, the only place they'll allow you to do that is going directly into the joist. You can't use those in the ledger. Well, you can use them in the ledger board. You can't do it on the 45-degree angle, because if you do, it's not even going to begin to penetrate the ledger board, as I'm showing you here. You can go straight into the ledger board. I hope you get, can you guys see my mouse?
Yes.
Okay, good. Because this would be really frustrating if you couldn't. You can use these short nails going straight into the ledger board from the joist hanger. But when you do that, you're going to reduce the load capacity of that joist hanger down to 64%. So it's a significant reduction in load capacity, but going on the 45, that's not allowed at all. And so something I like to do, every new construction, well, I shouldn't say just new construction, especially new construction, but even existing houses, one of the tools I carry around in my tool pouch is this, I guess Jim Vaughn invented this one. He put his name on there. It's a little pry bar, just a tiny little pry bar. And if they use the wrong nails on those joist hangers, you can pop them out with your cute little pry bar. That's all it takes. Now, if it's the right nail, you ain't getting it out with that. But I'll go around, I'll pop out one nail and say, look, they used the wrong nails. Fix it. Yeah. Take pictures of it. Sometimes you don't even need to pop the nails out. Sometimes if the joist is held back from the ledger board just a little bit, you can take a flashlight and you can actually see the tips of the nails. That's even easier than popping the nails out. And you'll see this on existing construction too, of course, but we're just a little bit more diligent on new construction because, well, it's just more embarrassing when you find this stuff on new construction. Here we got nails going into the wrong holes. Well, they made their own holes. They're using a pneumatic nailer. They're just going way too fast and they punched right through the metal. These nails are doing pretty much nothing. Missing nails at joist hangers. We all know to look for that. This was wild. How high did they have to have the pressure set on their nailer to punch right through the hanger? That was, I don't know. That's not a common defect. Look for missing joist hangers, of course. Look for missing nails. Look for improper joist hangers. Anytime you've got a skew where it's turned, it's not a 90-degree angle with the joist coming in, you need to have something called a skewed hanger. That's for angles. And boy, they really messed up here. They got this toe-nailed in. I think someone just forgot to come back with a hanger later on. They didn't have the right hanger and they called it done. Now this detail here, couple things going on. Number one, we obviously have the wrong hanger. This hanger is not meant for dimensional lumber. Even if it was meant for dimensional lumber, it's not big enough. We've only got 2 of the members supported by it. We're missing support on that 3rd member. But finally, and this is one where I'd be looking for somebody in the room to raise their hand and point out the last thing here. This is kind of a newer detail in the code, and it's section R507.9.1.1. And it says that deck ledgers shall not support concentrated loads from beams or girders. In other words, you can't have a big old beam attached to the deck ledger board. And I shouldn't say big old beam. You can't have any beam. You can put joists on the ledger board. That's it. If you're going to have this detail, there's a couple ways you could do it. One would be you would have that beam let into the house, and it would bear on the top wall of on the top wall plate for the house. It'd have to actually penetrate the ledger board. It'd have to go all the way through. That would be one way to do it. You might need to add some additional support underneath it. I've seen that done. I've seen it retrofit where they beef up part of the wall to support this concentrated load. That would be acceptable. Another way to do it would be to have a post right next to the house. Now, that presents its own challenges, because what's that post going to be supported by? You need to have a footing, and that footing needs to be installed on undisturbed soil. Well, right next to the foundation, you're going to have disturbed soil. So how's that supposed to work? I don't know. I don't design the repairs. I mean, I guess if I did, you could maybe do a helical pier, and you could have that helical pier going way down into the ground below disturbed soils. But at it's an ugly detail. Oh, and I'm Skip is saying in the chat, I got my chat open here. You could also have it designed by an engineer. That's always an option. Yes, thank you, Skip. Could definitely do that too. Always the third option for all these defects. All right, so let's look at this deck. New construction. We got a few things going on here. First off, what are we doing here with our loads? We've got the load from all of these joists is going to be attached to this beam. That beam goes to these, and then that goes into the house, into the ledger board. Is that a ledger board? I don't know. That is so darn tiny. There's no way it could possibly support all of that. Not only that, but I do like the fact that they didn't just attach the deck to the cantilever. That is something we should always be looking for. You're never supposed to have cantilevers supporting loads like this. And the reason this illustration is courtesy of Dr. John Bolden, longtime ASHI member. He gave me permission to use this. This is what happens when you have a deck attached to a cantilever. What could happen when you got a deck going to a cantilever? You have no support underneath it, and it can easily break away from the house. So that's the problem with that detail. So we had a cantilever. All of the load is going to one tiny little area. It's technically a ledger board, but boy, it's so tiny. There's no way it could support this load. So how do you fix it? I don't know. I'm going to punt. I'm going to say, have someone qualified fix it. This is going to take some work. Maybe an engineer. That might be good. Stairways, look out for stairways. Something I found is that there's no good prescribed detail to attach a stairway to a deck. So we see all kinds of crazy options. And by the way, the previous slide here, just the goofy stairway stringers. A lot of the time when you got a rookie using the saw, cutting the stairway stringers, they don't think through the depth of the treads. And the first tread is way off and the last tread is way off. That's what happened here. So they fixed it by scabbing on deck boards. Awesome fix there. But back to stairway stringers. Look what we got here. We got this strap. This is not at all meant for decks. It's going to be doing absolutely nothing. And someone had an idea. I don't know what they were thinking. They thought this is going to do something. This is absolutely worthless. Someone needs to fix it. This is not how you attach a stairway to a deck. This is also not how you do it. These are deck stairway stringer hangers. They are meant to do this, but they're installed improperly. If you look at the diagram there, or the illustration at the top left, it shows how it's supposed to go. You're supposed to have it nailed into the back side of the framing, then wrapping around underneath it. If this were properly installed, these stringers would be way higher on the deck, and then you'd have the nails going into the wood down here. When you've got nails going into the end grain of lumber with a manufactured product, it's probably wrong. Maybe there's some exceptions, but I can't think of any manufactured hanger or strap or fastener that Simpson's got, or any of those manufacturers. I can't think of any of them where they design it for nails to go into the end grain. Anytime you see that, your spidey senses should be going crazy, and you should be thinking to yourself, I think someone messed up here. So the improper hanging, here's another version of it, exact same defect. They just flattened out those straps, and they're not doing at all what they're supposed to be doing. I've got 10 minutes later. We are resuming. Please take your seats. All right. So getting back to decks, I started this class talking about guardrail heights. Now, if you're doing new construction, you got dead of winter, they haven't finished the landscaping, you're talking about guard heights, you're measuring down. If you write this up in your report and saying, hey, this is improper, it's too big of a fall, builder's probably going to make you look stupid. And it's just a matter of not knowing sequence. So if I write this up, the builder's going to come back, they're going to say, hey, look, we haven't done our landscaping yet. When we're done, we're going to raise the grade, and it's going to be a very safe 29 7/8 of an inch. And we're not required to have guards at that point. And, they're right. And I mean, I'm saying it a little tongue in cheek, but it's understanding the sequence. So I would tell my client, look, when this is all done, it's probably going to be code compliant technically, but at the same time, I'm not here to do a code inspection. You may want to put a guard up for safety anyway. This isn't something you go back to the builder with. They didn't do it wrong, but it's something you may want to add. So think about this for safety. It just understanding that. All right, we already talked about this stuff. I went out of sequence. And here, look, depending on which rock I measure to, I could still say it's more than a 30-inch drop off. All right, looking at patios, always make sure the patio slopes away from the house. One of my little tricks, I like to keep a little garden hose in my truck, one of those little collapsible ones. And if there's some place, even on existing houses, where I really want to check grade and see where all the water ends up, sometimes I'll just run a bunch of water close to the house. And I'm not going to point it at the house or away from the house, just have it running perpendicular to the house and see where it all ends up. At this particular house, you could see all the water went right back against the house. This is a big defect. And how do you fix it? You start over. And that's what they ended up doing. They came out brand new stamped concrete patio, and they ended up jackhammering the whole thing, having to redo it on a new construction house. Unbelievable. And this is another one of those things about knowing your codes. In Minnesota, I don't know why, this is another stupid omission we have in our code, where in the national IRC, there's a section that says the area of floor used for parking of automobiles or other vehicles shall be sloped to facilitate the movement of liquids to a drain or towards the main vehicle door entry. But in Minnesota, we deleted that from our code. I don't know why, but we deleted it. So this is not a code defect to have all the garage water pond inside and not drain out. However, it's really stupid. And you can see with my level there, it does slope back towards the house. And my comment, I'm not going to say anything about this being wrong. I'm going to say the garage floor doesn't slope so water drains away from the opening and it causes water to pond. have this fixed. Plain and simple. I don't need to reference code. It's simply understanding the meaning behind the code. We'll talk a little bit about manufacturer's instructions on siding. If you don't have a copy of it already, I strongly recommend getting a copy of the Adhered Concrete Masonry Veneer Manufacturers Association's installation instructions. They've got a fantastic, basically a book telling you exactly how to install stone siding. It's packed with illustrations and diagrams. It is pretty much synonymous with the building code. I'm not going to get into the whole history of why that is, but take my word for it. It's about the same thing as the building code. And pretty much every manufacturer of stone siding is going to rely on this, telling you how to install it. And here's just one example. They say if you've got a vertical transition between trim and stone siding, you need to have a 3/8 inch gap between those two. And then you need to have backer rod and caulk to seal that off. So when you got movement of dissimilar materials, it's not going to open up and you'll have this big nasty gap in there. Like I'm showing here, this would be an improper installation. This is also an improper installation. You're supposed to have a gap here between the stone siding and the ground. If you don't, you could have water wicking up into the siding. And they've got a nice illustration showing exactly how that's done. And I'm going to skip over the rest of these. You can follow along in the free handout I gave you. I'll give that link again at the end, but it's a bunch of installation errors right next to illustrations showing how it's supposed to be done, all courtesy of the Manufactured Veneer Manufacturers Association. Manufactured stone veneer. Excuse me. This detail, though, I do got to point this out because it is so common. I've never seen this done right, not on one new construction house. And it's where you've got this stone cap and then they've got flashing coming down on top of it. They're supposed to seal the space in between that. And this illustration shows it nicely where it says bedding seal under flashing. This needs to be sealed. It is never sealed. And I simply take something flat and skinny. I could even take a business card if I want to and slip it up underneath there to prove they did not seal this. And when it's not done, you can have wind driven water going right up underneath that. And we're trying to prevent bulk water intrusion. Other really common things we find on new construction is when you have composite siding, things like LP Smart Side or James Hardy siding, where they bring the siding too close to the shingles. Manufacturers dictate what that clearance should be. Typically, it's going to be a 1-inch gap there. And when it's brought too close, you're going to have water splashing up against the siding. Not only that, but that cut edge needs to be painted. And that's where we take out a mirror. I like to use the little dentist mirror and just go underneath it and make sure that they painted it. And if they didn't, you're going to have you got the potential. I won't say you will. You have the potential for premature deterioration at all of these cut edges. And that's something we're looking for. We need paint at the bottom, any of the cut edges on any of the siding. If they overdrive the nails, there's a fix for it. They tell you exactly how it's supposed to be done in the installation instructions. If it's overdriven just a little bit, you can seal it. If it's overdriven a lot, you seal it off and you re-nail it. They tell you exactly how to fix this stuff. But look for overdriven nails. Look for, again, missing paint at the edges. This is a butt joint where we're missing it. And also pay attention to those butt joints, depending on the siding. For LP Smart Side, for example, when it's initially installed, the manufacturer requires a 3/16 inch gap at those butt joints. However, they do that because they say the material is going to expand over time. After it's rained on it a few times and it weathers, it will expand and it's probably going to stay at about that size. So if you've got siding that's a year old and you see this and nothing is buckled or deformed, you don't have anything to say. It's fine. But if you see this when it's brand new, it just went up and they didn't leave a gap, it's probably going to expand in the future. And that's where you've got a problem. So think about how long it's been there. Is this really a problem, or am I just causing a problem where everything is fine. Different ways to treat the butt joints. Probably the best way to deal with a butt joint is to have a piece of flashing going up between it, but it's not the only way to do it. Depending on the manufacturer, they may allow you to caulk them. I think that's a hideous way of doing it. Or they can use joint molding. That's pretty ugly too, but it is allowable. Surely the best way is to have concealed flashing, piece of metal in between there. And I like to just, I'll take never mind. I don't have time to get in all these little details. Okay. When you got siding coming down on top of flashing, manufacturers require a 3/8 inch gap there. And what do we have here? We got about a 1/8 inch gap. And the reason is so you don't have water wicking up into the siding, and also to give somebody room to paint underneath it. Now, how are you going to get a paintbrush underneath here? It's not going to happen. So need to have more room there. And let's see here. Oh, and Jim is clarifying in the notes here, 2-inch clearance for the shingles for Hardy products and a 1/4 inch gap. Yeah, different manufacturers are going to have different gap requirements. It's yeah. Bottom line is look at the manufacturer's installation instructions. Get them, pay attention to them, know it. More stuff. Electrical. Don't get complacent on new construction. The first time I came across a double tapped AFCI breaker, this was a long time ago. It was when AFCIs were kind of new and they just started requiring them in a bunch of different areas. And I saw this and I was really confused. Like, okay, maybe there's this new rule for AFCIs where it is okay to double tap them, because this isn't the traditional type of breaker that you could double tap. So I was really confused. And I ended up just making a phone call to the building official for the city after I was done with my home inspection. I took photos of it and I asked him, I said, hey, you're out at this house. You signed off on this a couple days ago, but we've got a couple of double tap AFCI breakers. Is it legal to do that now? Is there some change? And no, absolutely not. So, okay, well, you signed off on it. What's up with that? And he said, what was that address again? And he got super huffy and he goes, well, that builder is going to have to go back out there and fix it then, because that's not okay. I said it as tactfully as possible. I said, well, how come you signed off on it? I mean, your signature's right on the panel. He said, well, I know that builder and I know that electrician well, and they do a good job. I don't look inside all their panels. All right. You can't see my video, but my jaw is on the floor right now. I mean, this was just mind blown for me. Okay. This was some great insight. I can't believe he admitted this to me. I wouldn't have said that aloud, but I've looked at new construction way more carefully ever since hearing this admission, where he just blatantly said he gets complacent because he knows the builders, he knows the electricians, and so he doesn't totally do his job. So look out for all that stuff. This is in the handout. You can copy this down. Just a bunch of areas where you're currently supposed to have AFCI and GFCI protection. I believe this illustration, I'm pretty sure Charles Buell put this together. Nice modern requirements there. For some of these updates that came with the 2020 NEC, and there's even more coming with the 2023. I'm not going to even touch on these. I'm sure Douglas Hanson will be talking about some of those later on today. So we're going to skip a few of those. Let's see. I know you guys know about CSST and bonding. I was reading through your home inspector requirements yesterday. You guys even have specific language you need to use when it's not right. Thought that was fascinating. So I won't harp on that, but surely it's something you're all looking for. This is a good example of improper bonding. What they've got is they've got a bond wire coming to the low voltage terminal bar. This terminal bar is for low voltage stuff. It started being required in the 2008 version of the NEC, and it's to bond things like the cable TV and phone and stuff like that. It is not there to bond your CSST. And if you got black CSST, That is the arc resistant stuff. There's nothing special you need to do with that. It's good the way it is. Although in Minnesota for a while, they were bonding it anyway, because our code was a little, we had a little lapse in our code. But the purpose of those little bonding terminals is to eliminate this stuff. What you're seeing at the top of this meter socket, we've got just this little clip that goes on the side of the panel to bond the cable TV or whatever it was. Those inter-system bonding terminals are supposed to eliminate all of that. And this was just a hilarious version where we've got this inter-system bonding terminal, if you want to call it that. It's just a little bonding bar, and they use their clip anyway. Didn't know what it was for, I guess. Paying attention to bonding at the bottom here, we've got we've got a copper pipe. We've got a bonding terminal, and it's wrapped around the tape. We would all see this. We would all note that, of course. Don't fix it. I know how tempting it is to just take your screwdriver, loosen it a little, slide it up, and fasten it back down. I did that. I tried doing something like that one time. There was a loose clamp, and I thought I'll just do someone a favor. I went to tighten it a little, and the clamp snapped. Now I'm doing electrical work. Now I'm having to go to the store and get a new clamp. Last time I ever did that. Pay attention to smoke alarm placement. I don't know about you guys, but I mean, I know Skip's on here. I won't get Skip started on photoelectric smoke alarms, but we recommend them on every inspection we do. We check every smoke alarm, checking to see which type it is. If they don't have photoelectric, we recommend adding it. We don't write this up as a defect on new construction because it's not a defect. It's not required for you to have this, but it's something we recommend. And also we're looking at placement. Manufacturers are really specific about where they need to be placed. It's no closer than 4 inches to the ceiling, no more than 12 inches. No, Skip says, please do. I need a good rant today. Skip, I'd love to spend the next 2 hours talking about nothing but that, but I have 21 minutes left and I am through approximately half of my slides. So we'll power through a few more things here and we'll call it a day. Looking at this electric panel, it's recessed way too far into the wall. And you know what? I shouldn't say recessed way too far. It's recessed into the wall. The panel needs to be flush with the surface of the wall when you have combustible construction. And when I say combustible construction, I'm talking about a wood framed house. That panel needs to be flush. Look for all the obvious stuff, nails coming into the panel, missing knockouts. In the attic, I don't know if you guys require it, but in Minnesota, we're required to have passive radon mitigation systems. I'm gonna skip a few of these details here, just for time's sake. Okay. How could somebody possibly put this in and think it's okay on new construction? They had a really tall ceiling, and that cord would not reach the receptacle, the outlet. So they used an extension cord. Who does that? And you know, even if it wasn't plugged in, you could probably look at it and think to yourself, is that going to reach? Check the auto reverse sensors. I used to always tell people those auto reverse sensors need to be within 6 inches of the floor because of child safety. You know, if you're going to, or have some small pet or whatever, it needs to be close enough so it's going to pick them up. I was totally wrong. I don't know who I heard that from. Somebody told me that, and I've been repeating it most of my home inspector career. That isn't at all why the sensors need to be close to the ground. They need to be there because you got this lever action when the garage door opener is closing, and the force exerted is like 10 times as much for that last 6 inches of travel because of the lever action with the garage door opener. That's why you need the sensors way down at the bottom, because that's the greatest force exerted. But so if you're explaining it to your clients, that's why. But look for the sensors to be much closer to the ground. Measure the height of the buttons on the door too. All the manufacturers have the exact same label, supposed to be affixed to the wall, and it says that the wall controls need to be at least 5 feet above the ground so little kids don't operate the door. Of course you want to measure from where a child's going to stand. You don't measure from the ground. A lot of builders will measure from the ground. They'll get into arguments with you about it. And they'll say, oh, that's more than 5 feet from the ground. This is the ground. Common sense. Where is a kid going to stand to open this door? So measure from where a kid would stand. Just some fun photos. You guys, there's nothing earth shattering in a few of these, but look out for it. Anytime you see modifications, cuts to engineered beams, it's probably not supposed to happen. If you can, try to get your hands on the original plans. See if this stuff was part of the original plan. See if it was supposed to be done that way. Hangers. These are stairway stringer hangers, and they're using them as skewed joist hangers. Totally not the right product for this. There's another shot of it. This is the wrong hanger. If the wood doesn't fit in there snug, it's surely the wrong hanger. It's used for a different piece of wood. This is when you got hangers bent up like this. Now, maybe if you had solid wood coming all the way down and it was flush, maybe it would be okay. But as it is, no, this is not how it's intended to be used. When it comes to notching and boring of manufactured joists, I-joists, the manufacturer's installation instructions are all very, very similar. I've read through all of them, kind of comparing notes side by side, and there's not much difference. There's some subtle differences. You know, one might say you can cut within an eighth inch of the web, and another might say a 1/4 inch of the web, but they're very similar and stuff that they all have in common. You can't mess with the top or bottom flanges. You need to leave those alone. You can't make any modifications. This would be a good example of what you can't do. Now, I know we make this joke that plumbers should never have sawzalls, but really, is this the plumber's fault? I mean, the toilet's got to go there. There's nowhere else the toilet's going to go. It's going to go in the center of the space, and the carpenters need to come back and fix it. That's the bottom line. I can't fault the plumber for this. He had to put his toilet in, or they had to put their toilet in wherever it goes, and someone needs to come back and fix it. Another example of that where they took a nasty chunk. They cut all the way through this one. This needs repair too. As far as putting holes in manufactured joists, you can put a hole pretty much as big as the webbing. This particular manufacturer did say you can cut all the way through the webbing until you're within 1/8 of an inch to the top or bottom flange. That's how big of a hole they allow. So, I mean, it's gigantic. And when you're dealing with the ends, though, they don't allow anything at the ends of their joists, except for some knockouts. If it comes with knockouts, you can put holes there at the ends, but otherwise you got to leave the ends alone. Different manufacturers will tell you exactly how close to the end you can get, but this is a red zone. That's a more important area. And they also say if you have cantilevers, you need to have fairly small holes, generally nothing more than 1.5 inch in the cantilever. And if you are going to have really big holes, it seems counterintuitive, but at least it does to me. When you got big holes, the best spot to put them is actually in the middle of the span. Yeah, I don't know. I'm shrugging on with my camera off. You can't see it, but that's what the manufacturers say. All right, those are just a few notes on manufactured trusses. Again, I said it before, I'll say it again. Look for changes. Look for things that maybe look like they weren't part of the original design plans. I remember there was one house I was inspecting where they wanted to eliminate a wall, and this was the builder's solution. They put this big beam in, and they hung the beam from a truss. Now, if you're not dropping your jaw, then you need to go back to Home Inspector 101 training for stuff like this. Trusses, they're designed to support the roof and the ceiling, and that's about it. This is egregiously wrong. But it had passed the building inspection. This was on a pre-drywall inspection. Again, I talked about deck stairways. Same thing applies to interior stairways. This was actually a house for one of the home inspectors on our team. They didn't cut the stairway stringers right. So the top tread was way short. The bottom tread was way high. You know how they had to fix it? They had to tear out that whole finished stairway and redo it. And my inspector made a stink with the building official, and they had to redo it. When you're looking at spray foam insulation, just check to make sure it's all uniform. If they don't have the mix correct, this is what you end up with. I don't know if it's standard in your area, but all we've been using at the rim joist in Minnesota for about the last 15 years is spray foam insulation, maybe the last 20 years or so. All right, HVAC, we'll power through a few more slides and call it a day. I got 13 minutes here. Check the slope on any condensing furnace pipes. It always needs to slope, so water is going to drain out. You should never have standing water sitting in there. On these examples I'm showing here, we've got dips where you're going to have standing water. That needs to be corrected. When you've got pipes passing through unconditioned spaces, the manufacturers of these furnaces say that it needs to be insulated. The inset I'm showing here is just a screenshot. I took a picture of the installation instructions from the manufacturer saying, if it's going through an unconditioned space, you need insulation to help prevent excessive condensation. If you've got grommets, gaskets on the furnace cabinets, it probably tells you that this is supposed to be sealed off. And for it to be a true category 4 direct vent appliance, you can't have openings between the flames and the rest of the air in the house. This is an unused opening, needs to be sealed off. Here's another opening in a furnace cabinet that doesn't belong. This is a field fabricated opening. Someone took their Christmas tree drill bit and they drilled right through the upper to lower cabinet to run their wires. And now every time that blower fan kicks on, it's going to fight with the flames and it's going to try to pull exhaust gas down into the lower cabinet. Be on the lookout for modifications like this. If you're doing pre-drywall inspections, it's fun to find stuff that you wouldn't find otherwise. This was just a completely smashed duct. They were using rigid ductwork, and then they transitioned to flex and then went back to rigid again because they had this tiny little hole they had to pass through. You're in that far bedroom at the end of the house. There's barely any airflow coming out of the register. And then the client's asking you why, and you're kind of scratching your head. If you're not doing pre-drywall inspections, a lot of the time you don't ever get to figure this stuff out. But if you get the luxury of doing it, sometimes you can find stuff you wouldn't find otherwise. There's no way I'd get to the bottom of this. I'd just say, I don't know why you got bad airflow. Check with the builder. This was one of the scariest finds I ever found during a home inspection. This was the exhaust for the furnace. We had PVC exhausting the exhaust gas, and they forgot to glue one of the joints, and I could smell it. I knew there was something funky going on, and I brought my ladder into the basement and I looked over this finished space to find this. It was a disconnected joint. I saw in the chat, someone said, is there a required clearance between a bathroom exhaust fan and a supply air vent? And when we're saying a supply air vent, I'm assuming we're going to say like a heat register or something like that. I don't know of any requirement. Maybe there is HVAC vent. Yeah, I think I got it right, Scott. I don't know of any requirement. Maybe if someone smarter who's listening could pipe in, if you know, but I'm not aware of one. I think it's more of a common sense type of thing. There are requirements for terminals on the outside. If you've got an air exchanger, that's kind of a generic term. Sometimes they call them heat recovery ventilators, HRVs, or ERVs, energy recovery ventilator. You got to have an exhaust and an intake on those things. And the manufacturers tell you they always need to be at least 6 feet apart. These are less than 4 feet apart. That's an improper installation. Also, if you got HRVs in your area, they're always supposed to be balanced when they first install these things. They need to make sure that the air coming in is equal to the air leaving, and they need to take measurements. They need to adjust the internal dampers, make sure it's all balanced, and then they put screws in these dampers to lock them in place. If that's not done, it was never balanced. If there's a balancing sticker on there, somebody pencil whipped it. They made it up and it's worthless. So always look for that. I don't know. Maybe you guys don't even have air exchangers in your area. We have them in basically every new house we build here in Minnesota, and they've been standard for quite some time. Don't take for granted the intake and exhaust. Turn the stuff on at the beginning of the inspection and make sure it's right. You can see this is labeled intake, and I'm holding a leaf there and it's bending the leaf backwards because it's blowing so much air out. They got the intake and the exhaust backwards. They reversed it. Why does it matter? Well, they like to put all the exhausts next to each other. I'm talking about like the clothes dryer exhaust, the furnace exhaust, the water heater exhaust, all these different exhausts. They like to put them all next to each other. So all these contaminants are all leaving at the same place. But if one of those is supposed to be an exhaust and it's actually an intake, you're going to be sucking all those contaminants back into the house. That's a big deal. That is a safety hazard. Having the intake and exhaust backwards, that's a safety issue. When you've got the combustion air intake, hopefully you guys have those and you know what I'm talking about. It's something that brings air into the house. They need to be at least a foot above the ground. I know your mechanical code says the exact same thing. This is too close. It's going to get dirty way faster than it should. I'm not going to explain all of these things here. Oh, this one I got to talk about. When you've got a gas fireplace, something we like to do on existing houses is use a combustible gas detector and run around the outside of that fireplace with all of our exhaust fans running and make sure that there's not exhaust gas leaking back into the house. If there is, if it sets off our combustible gas detector, we follow up with a test with our combustion analyzer. This actually measures carbon monoxide and we'll verify those readings. And you know, what you're looking at here is 64 parts per million raw of carbon monoxide leaking into the house. And when you do air adjusted, it's nearly 400 parts per million of carbon monoxide. That's the undiluted reading. That's a lot of CO just leaking into the house around the gas fireplace. And it happens a lot. And it's much more dramatic when we're putting the house under negative pressure by turning on all the exhaust fans and running everything at the same time. That's a big defect. However, I'm going to caution you guys. There's certain rules for doing that test. It depends on which standard the fireplace was manufactured to. If it was manufactured to ANSI Z2150, you're not supposed to do this test until that fireplace has been running for 45 minutes. And if it's manufactured to ANSI Z2188, you can wait 15 minutes and then take the test. And the difference between those two standards, if it's the newer standard, ANSI Z2188, that gas fireplace is approved to be used as a heating appliance. You can connect it to a thermostat. If it's the old standard, Z2150, it's simply a decorative gas appliance. It's not meant to provide heat to the room. It's not intended to be connected to a thermostat. Now, I know you're wondering, what's the difference between those two fireplaces? And I'm kind of winking when I give you this answer. The difference between the two is the standard to which they're certified to. In other words, nothing. It's just the standard they're certified to. It's what they've been tested to. Otherwise, for all intents and purposes, the fireplaces are identical, but these are the rules. And if you want to know, you just look inside the fireplace and it's going to say right on the data tag which one it has been built to. Some of the inspectors on my team, I know they like to get a little bit lazy. They don't want to take the time to look, and they just say, I run all fireplaces for 45 minutes before conducting this test. I don't know, it gets pretty hot at that point, but still, you need to run it for a long time if you're going to do that test. And if it's new construction, I got burned on this. I got made to look really stupid where I found a fireplace leaking a bunch of exhaust gas. As it turns out, the standard from the manufacturer says that it needs to have been running for at least 8 hours. On a brand new unit, it needs to run for at least 8 hours prior to doing this combustion test to see if it's leaking combustion air. So I was wrong. On new construction, we don't do this test anymore because it hasn't run for 8 hours. We only do this on existing houses now. Maybe this is going way above and beyond what you guys do anyway. But if you're ever thinking about it, I want to caution you. You can't do it on new construction unless you're going to spend a full 8 hours at the inspection. And you're probably not doing that. more fun stuff, just fun photos. We're paying attention to all these HVAC vents. So often the ductwork is disconnected. It doesn't come flush. When you've got toe kick registers, I don't even take the time to try to figure out if a toe kick register was installed properly or not. I just assume it's always wrong. I get out my impact driver every time and I take the cover off, take my flashlight, and I get down there with my camera because I know it's wrong. It's always wrong. And I've got a plethora of photos showing it. I mean, I'll just power through a few of these. Look at this ductwork. It doesn't even come close to the front of the cabinet here. Huge gap here. They didn't even bring the ductwork. They didn't even try it. They're just pressurizing the underside of the cabinet and hoping the air is going to know where to go here. This is completely smashed shut. Whatever you do, don't stick your hand in there. You're not getting it back. Over and over again. Look at this tiny little slice. Tiny little slice. There's going to be no air coming out here. So I always know this is going to be wrong. I've got a story to tell about this that I don't have time for. Bottom line is this was 5 years old. They didn't get the ductwork right. And this is what the cabinet looked like after 5 years of having cold air blowing underneath it, making that cabinet super cold and moist, leading to a bunch of condensation. And the buyer said they never had a leak. Now, I don't know if I believe them. It kind of looks like there had been some leaks, but it can lead to condensation. Always look behind clothes dryers. Make sure the ducts are properly connected. This applies to new construction too. I'm not going to explain a few more of these. Always turn on the furnace and check the exhaust and intake at the outside. Make sure they got it right. Take the time to read through furnace installation instruction manuals. Make sure the venting terminals are right. You guys see what's going on here? They even got it labeled. This says intake, this says exhaust. The infrared camera clearly shows this is the exhaust and this is the intake. When they got it backwards, it means the exhaust gas is going to be spitting out of here. It's going to rise right back up. It's going to suck into the intake. And those exhaust gases, we all know the exhaust gases from natural gas combustion are extremely corrosive. It's going to prematurely destroy the inside of that heat exchanger. That thing is going to rust out quickly when you have an installation like this. And that's not the only problem with this, but that's the most obvious one. And if you're not running it, verifying those terminals at the outside, you're not going to find out about this stuff. So, and I've got way more. You guys can look through the rest of my handouts. I'm going to skip all the way to the end. And I'm going to put a QR code on here and you can scan it with your phone. We do a podcast at my company at Structure Tech, and Bill is no longer a part of it. Now it's just me and Tessa, but we do a podcast every week. Every Monday we release a new episode. I've got a blog. I've got a new blog topic pretty much every Tuesday. Usually I have videos to go along with it. If you'd like to subscribe, you can find us. All of that is on our website at structuretech.com. And again, here's the link for the presentation, or you can scan that QR code. That'll give you the presentation.